Welcome back to the channel. Hope everybody's doing well, and in today's video we are taking a look at this little multifunction process calibrator from Extech Instruments. This instrument here is the PRC30 and is a top of the range instrument that Extech offer in their range of calibrators. At the bottom end of the range, the PRC10, which is a current calibrator. Then the PRC15, which is a current and voltage calibrator, the PRC20, which is a thermocouple / millivolt calibrator, and then the PRC30 here, which is all those units combined together really. And as you can see here, it arrives in this plastic case that is designated as a stick-on label here. Fairly okay plastic case. It's got a metal hinge down at the bottom here. And we'll flip them around. We've got a couple of plastic latches here to lock it up, and then we've got this really annoying piece of eggshell foam that keeps dropping down, and then we have a compartment for the meter itself in there. We get a DC power converter here because this will actually run from either batteries or plugged into the mains. However, you cannot charge the batteries that are in there. It's just purely just an alternative supply. You get a range of the mains plugs to swap the adapter over to suit your socket outlet for wherever you are in the world. And then we get a set of PVC test leads. They have the GS38 caps on them that do come off. You can take off, and then you can plug on a fully insulated crocodile clip as well, so you can end up with the leads like that. And you also end up with a couple of thermocouple leads. You get this K-type here in the yellow, and then you get this white one that they call a universal. It's not designated for any particular type of thermocouple, so I'm not quite sure how that works. Probably not something I can test too well either. So I'll put our meter out and we'll put him over to one side because we don't need him now. So looking a bit more closely at our instrument here, our orange surrounded here, this is the soft rubbery type surface, and then we've got the hard plastic on the green here. Our buttons are soft touch as well, and they've just managed to switch them on. And then there's our DC jack there for 9 volts to go in should you want to. We have a tilt bail on the back here, which is a rather unique design. You can see this is its default position, also folds flat and shut in there, but you take this out, you can then flip the top out in that manner, and then this will rotate, and this section here will push down and lock in place. I can't do the same with, I can do one side with this top piece, but the other side doesn't want to go. I doubt I'll be able to show it on camera. It's not really working that well, but I guess you could hang this up should you want to. If we zoom out a little bit to do that, so you can hang it up on a panel, but you can't seem to hang it vertically. That's the kind of angle that you appear to get with it really. So I'm not sure whether my unit is faulty or whether it's just a little bit of a poor design. I feel if I push that more I'll break the tilt bail, but you do have that. It may be my unit and the other units are fine, and then you can flip this and lock it in place and hang it completely vertically. Don't know. Okay, so we've changed over to our milliamp function measure milliamps here. We've got 10 milliamp resolution on here. Put our 4 milliamp, turn him on. I'll smack on 4.00, that's a good start. 8 milliamps, 12 milliamps, to 16 milliamps. Yeah, this is all smack on, isn't it? Just try and be cheeky. 19.10. Can't complain at that. Pretty stable. Oops. Yeah, you can't complain at that, can you? So that's the milliamp, measure milliamp function going on there. In milliamp function, we are 0.01% plus 1 digit with a resolution of 10 milliamps there. And you can see it's been spot on with all the measurements I've made. I'm trying to source voltage now. 20 millivolts. So to change to our function, we need to hold in again. It doesn't like to change function when it's in source mode, so we've gone to measure there. Now on measure millivolts. So in measure millivolts, we are 0.01% again plus 1 digit, and we have 1 millivolt resolution when we're in millivolt mode. So 1 millivolt, let's turn him on. And that's our 1 millivolt there. 10 millivolts. Okay, spot on again. Millivolts on 101 millivolts. Okay. 252 millivolts. So we're creeping out a little bit here. And then 503. So we stay in millivolt mode, I believe, up to 2 volts. So there's 1 volt there, and we are 1.0056 millivolts. So we're out a little bit. I'll have to do the calcs at the end and see where we are. 1.9. 1.9, 10 millivolts out now. Okay, and if we got 2, so 2 volts, there's our resolution change there, and we are on measuring volts now with a 10 millivolt resolution. And we have gone back down to being 10 millivolts out, aren't we? 2.01 volts. We should be able to go up to 25 volts now. Let's just try 5.1. 10 volts, 10.05, so millivolts we are, or voltage as function as well, we're a little bit out, aren't we? Come back in again there. 2.9, 2.91. There's our 20 volts there, which is full range on this, I believe. Let's just try. Yeah, we go over range then, 20.1 volts. Okay, so that's our measurement functions there. So I'm going to have to get the DMM out now to change it around to test the source function on this instrument. So we're currently set to measure millivolts. To change it to source, you hit the IO at the bottom here. It now shows source, and the accuracy and resolution is the same, so we're 0.01% plus 1 digit with a 1 millivolt resolution in millivolts and 10 millivolts resolution in voltage. Source function, we're currently sourcing 0 millivolts. To change it, you just hit the button here, the arrow keys you can move around, so we're 1 millivolt and we are 1.2. That's let's go there, so you can push this out all the way. See the cursor moving over, so I hit the up button now, we are straight into 101 millivolts, and we are pretty good with that one. Go back down to 0, go that way. It's 11 millivolts there, and we are 10.99. Yeah, hovering there, so that's all fairly good. Let's go to zeros, all the way across again, and we should be able to go into our volts now. So that should be 1 volt or 1000 millivolts, and we are 0.995. So there's it. Let's go to 2000 millivolts. That's interesting. 1.99. Okay, it doesn't like me going. So there's no automatic change from millivolts to volts on this hit the unit key, then we change it to volts and it resets itself to go back to 0. So I guess that's protecting you a little bit there, isn't it? We can go to 10 millivolts now. We are 10.9ish. Sorry, 9. It's not so good on the 10 millivolts there, and 20 millivolts we're a little bit more stable on. System out a little bit there. So not the best of functionality now. If we go up to 100 millivolts, we'd expect better stability there, but we're on 98.9. Yeah, not the best. 200 millivolts. 500. 497. We're creeping out a little bit there, aren't we? Let's go up to 1.5 volts. 1.49. 2.5. 2. Stick a 1 in there to go to 12. 1.961. So it doesn't let you go above 20 volts. Go straight up to 20 volts there. And we are 19.992, so I'll have to do all the calculations to see if these are within spec. We need to look at milliamps measurement now, don't we? So if we go, generally speaking, it will not let you change function too well. It goes back to measurement function when you're in source mode. It doesn't like to change modes when you are sourcing, which again is protecting you, isn't it? So that's not a bad idea. We need to change our jack over. We need to go to DC amps, change our mode, and we are sourcing 4 milliamps. As soon as you change the source, then there's a slight delay, but the actual output comes on automatically. There's no manual control of the output here by the looks of things, other than changing it between measure and source. So we've got 4 milliamps there. That's good. That's nice and accurate. 4.01. Yeah, that's not bad, is it? Let's go to our 8 milliamps, and we are 8.00 again, 8.03 there. So perhaps not got the best resolution for calibration function, but it seems to be fairly stable and accurate. Let's go up to 16 milliamps, 15.999. And then 20 milliamps. It's not 20.00, 19.99. Yeah, floating around a little bit, isn't it? Let's put our PLC rate up. So we are 19.999, aren't we? So 1 milliamp out. Okay, that's all those functions. It all seems pretty good. What I'll need to do now is sort out how to test the temperature function, which could be interesting. So we're trying our best with the temperature here. The temperature can only be sourced or measured out of the little thermocouple socket on the top there, and the connection into it I've got is not the best, so it's a little bit unstable, unfortunately. We are set up to K-type, degree C. You can change between degree C and degree F using the unit button here. That's degree F now. That's degree C. We are set our calibrator to 1000, and we're reading 999.6 to 1000.3, depending on how much I bash the connections. You can change between the thermocouple type by holding in the unit button, and you'll see it starts to go through these now. C, R, S, N there. You get thermocouple millivolts here, on that same range, so you have that function in there, and then we go to J, back to a K type there, and the only other thing you can do when temperature is to turn off the cold junction compensation. You can see it's turned on there at the moment. If I hold in the IO and the MEM button, it turns it off, and you see our temperature has changed to 980 degrees C, but we wanted to check the cold junction compensation in the meter itself, and it appears to be working reasonably well. Let's say that's 1000 degrees C. We can just there's 901. I've done this try to set up as stable as I can offline, so those are the results that I'll post at the end of the video, but you can see it's pretty reasonably accurate. Our tolerance is for thermocouples is 0.05% plus 1 degree C, and in our resolution we are 0.1 degree C resolution in measure, but in source we are only 1 degree C resolution. So you lose a bit of resolution in the source, and there's 100 degrees C there. There's a 0 there. So we are 0.3ish out by the looks of it. But you can see that cycle around, I'm not quite sure, I'm not comfortable with the connections here. Yeah, don't know, that's the best I can do. I need to probably revisit this and see if I can set up make a proper lead up for it, get the parts, make a proper lead up that I can plug into the calibrators and do it that way. And that's the best I can do at this moment in time, unfortunately, but it seems to be a fairly reasonable result for the temperature measurement. So to test our thermocouple function output, we set it to source, and we are putting out 1000 degrees C, reading it with the MR9270S here. You can see we've got 1000 to 1100. 1100. Let's go, where did we go down to 500. And we are 500 there as well. And from there we went down to 250. Just copying the when we did the measure function. And we've got 249, and then we go down to 100. And 98, 99. Yeah, that's okay, and then we can go down to -10, didn't want to do that. 10 degrees C there, and we are 10 on there, and then taking down to our 0. And we are 0, so that all looks to be pretty much okay. We haven't covered the memory function here. You can step the stuff, so these can be pre-programmed, and when you keep hitting the set key, it takes you to the preset values that it saves for each there, so you do have that function that you can program it yourself. There are only 5 memory functions there, so you do have that you can do with it as well. It's not something that I use an awful lot of, but that's sourcing our temperature function. So now we go away to the computer, do some maths, and pop up some results for you. These are our results tables here. You can see the very top row is the milliamp. For source and measure, you can see that the values are all totally within spec, which is mainly driven by the plus or minus 1 digit, which is equivalent to 0.01 milliamps. Move further down, the main issue with these results appear to be with the millivolts and volts. You can see I've got a mixed bag of results there. Some of them are in spec, some of them are out of spec, and there's no real pattern to it. It's not like some of them there. The middle ones are out of spec, sometimes it's at the end they're out of spec. So that appears to be where the main issue is for this unit. And finally, our temperatures were all found to be within their specification as well, although we did see a bit of instability whilst we were taking the readings with them. Now this unit itself, it was sold as brand new on eBay, but I'm not sure how brand new it had been, whether it had been used for demos or something like that. Recommended retail price on this is taking that from RS Components, which is £678. You can buy the unit from electrical test equipment suppliers like Test Meter and Tester for around about £560. Sometimes you see these on eBay. At the time of doing this video, there's a couple on eBay for £380, I think they were. I picked this one up even lower than that. As I say, I think they were just getting rid of it because whether they'd used it for demos or something. So I can't fully guarantee its pedigree that it is a completely brand new unit and it's therefore totally within specification. So the issues I've seen might just be something to do with this unit, and a brand new unit will be perfectly fine. That'll be it for this video. Thanks for watching. I hope you found it useful, and I'll see you again in the next one.